Hi guys, welcome back. Today I'll be teaching you all about AVL tree. So let's see what's this AVL tree. AVL stands for Adelson, Welsky and E.M. Landless. This AVL tree has two types of rotations. One is the single rotations and the another is the double rotations. In this single rotations we have two types again, that is left rotation and right rotation. And in double rotations also we have two types. One is the left right rotation and right left rotation. So let's first see what's this left rotation. Every node moves one position to left from the current position. Now here it's like 0, -1, -2. Then at this time what we have to do is we have to rotate it and take the middle term as the main root. Then right rotation. Every node moves one position to right from the current position. That is 0, 1, 2 is the balancing factor of this, but this is +2, so it has to be balanced, as AVL tree always requires 0, 1 or -1 as its balancing factor. Please do remember this. AVL tree always has the balancing factor as 0, 1 or -1. So here it is 2. So it has to be rotated from right side. And this middle term becomes the main root, and then these are the subroots. Next, left-right rotation. Every node moves one position to left, then one position to right from the current position. Now here this is the root given, consider. This is the main root, this is the children of this is. So this is 0, -1, as here this is 0. How we calculate the balancing factor is the balancing factor of left subtree minus the right subtree. Okay, so here left subtree is 0 and this is also 0 as it is the starting. So as this here it is one node, the number of node is 1 and here it is 0. So what we do is 0 -1, that becomes -1, so it has got -1. And here for this main root node we consider the number of nodes required present. So this is 2, so here and here it is 0, so 2 minus 0 is 2, so this is the balancing factor 2. So what we have to do is, it is imbalanced as it is neither 0 nor -1 or 1. So we have to first rotate it to the left and then to the right. So 2 goes in this position and 1 comes in this position, that is it forms this way, and then we have to do the left rotation, that is this is how it appears. Next, right left rotation. In this every node moves one position to right, then one position to left from the current position. Here also it is imbalanced as it is showing -2. So what we have to do is, first we have to do the right rotation. We have done that here. Then left rotation is to be performed. So let's move to the example. The example here is 10, 18, 20, 5, 3. So first we'll be inserting the first element. First element is 10. So there is no subnodes for that. So it has to be 0. The balancing factor is 0. So it is balanced. Next, 8 is to be taken. 8 is smaller than 10. So it has to be placed on the left hand side. So here there is only one single element over here and there is no element over here. So it has to be 1 minus 0. So it is 1 over here. So it is also balanced. Next, 20. 20 is larger than 10. So it has to be placed on the right hand side. Now here it is 1, it is 1. So 1 minus 1 is 0. So its balancing factor is 0. This is also balanced. Next, 5. 5 is smaller than 10, so it has to be placed on the left hand side. Again here it is 8 is present, so 5 is smaller than 8, so it has to be placed on the left hand side. Here there are totally 2 numbers and here it is 1. 2 minus 1 is 1, so balancing factor is 1, so it is balanced. Next, 3 we have to insert. 3 is smaller than 10, smaller than 8, smaller than 5, so it has to be placed on the left hand side. Now here there are 3 elements over here and 1 element over here. So 3 minus 1 is 2. So this is not balanced. So to balance it, we have to perform the left rotation. We have performed that left rotation. We have brought 5 over here and 3 and 8 over here. Now if we say 2 minus 1 is 1. So it is balanced. So this is the required AVL tree. Now we'll go for the alphabetic AVL tree. Here the series given is X, C, Y, B, Z, A. So first element we'll be taking is X. It is single, so it is balanced. Then X, or after X we have C. So C has to be placed to the left of X. So this is also balanced as 1 and 0. 1 minus 0 is 1. Then we have to insert Y. So this is balanced, this is balanced. Now it's turn for Y. Y should be placed on the right hand side of X. So again this is balanced as 1 minus 1 is 0. So this is balanced. Next B. B should be placed on the left hand side of C. So it has to be placed. Then 2 minus 1 is 1. So this is also balanced. Next Z. Z has to be placed on the right hand side of Y. So it has to be placed over here. And 2 minus 2 is 0. Again this is balanced. Next A we have to insert. A should be inserted to the left side of B. So it has been inserted. Now this 3 minus 2 is 1. So again this is balanced, hence is the required AVL tree. So in this AVL tree we have to just keep in our mind about the rotation, left rotation, left right and right left rotations. These are the 4 main rotations which are required, and we have to remember that the balancing factor is calculated by the left subnode minus the right subnode. Then that is the balancing factor, and the balancing factor for AVL tree must always be 0, 1 or minus 1. I hope you all have understood the better what is this AVL tree, how we should construct it. If you have liked my video, please hit the like button. If you have any queries and you would like to comment anything, please do comment it in the comment section. Thank you so much for watching my video. Bye bye.